as we're studying cells in our science studies, we notice an organelle. It's called a lysosome. Lysosome is spelled Lysosome. Lysosome. And what it is, it's a compartment that digests material that's kind of some waste products and just other material that's in the cell. It digests. It's a digestive compartment and uses enzymes to do the breaking down. And it's obviously very important because it allows the stuff that is no longer needed to be taken care of. And let me read something about this for you. Oh, let me first show you what it looks like. It looks like this right here. That's what it looks like. Now, what's interesting about the lysosome is that the main function of this is to serve as a digestion compartment, like I just said, and for cellular materials that have exceeded their lifetime or are otherwise no longer useful. In this regard, the lysosomes recycle the cell's organic materials in a process known as autophagy. Probably not pronouncing very well, but autophagy. Process of recycling these materials. They're no longer needed. Autophagy. Lysosomes break down cellular waste products, fats, carbohydrates, proteins, and other macromolecules into simple compounds, which are then transferred back into the cytoplasm as new cell-building materials. To accomplish the task associated with digestion, the lysosomes utilize about 40 different types of enzymes, hydrolytic enzymes, all of which are manufactured in the endoplasmic reticulum and modified in the Golgi apparatus. Lysosomes are often budded from the membrane of the Golgi apparatus, but in some cases they develop gradually from late endosomes. So they come a lot of times, they come out of the Golgi apparatus, but sometimes they form on their own and from the endosomes, which are vesicles that carry materials brought into the cell by a process called endocytosis. So endosomes may also create them. Like other microbodies, lysosomes are spherical organelles. I've already showed you what they look like right here. Okay, they look like a sphere. And contained by a single layer membrane, though their size and shape varies to some extent. This membrane protects the rest of the cell from the harsh digestive enzymes contained in the lysosomes, which would otherwise cause significant damage. So in other words, these enzymes that are inside the lysosome that are digesting these materials there's a wall or a membrane around them that protects the rest of the cell from those enzymes so they don't escape and they don't harm the rest of the cell. The cell is further safeguarded from exposure to biochemical catalysts present in lysosomes by their dependency for enzymatic activity, but the neutral environment of the cytosol renders most of the digestive enzymes inoperative. So even if a lysosome is ruptured, the cell as a whole may remain uninjured. However, that membrane is designed to protect the cell. The discovery of lysosomes involved the use of centrifuge to separate the various components of the cell. In the mid-20th century, the Belgian scientist Christian René de Duve was investigating carbohydrate metabolism of liver cells and observed that the cells released an enzyme called acid phosphatase in larger amounts when they received proportionally greater damage in the centrifuge. To explain the phenomenon, de Duve suggested the digestive enzyme was encased in some sort of membrane-bound organelle within the cell, which he dubbed the lysosome. After estimating the probable size of the lysosome, he was able to identify the organelle in images produced with an electron microscope. Very important organelle, one that's important to digesting certain waste products. Very important. And now we have a little better understanding of what it's all about. Thanks for watching.